I am going to show you through this quick video how to do a G4 blend. Now I have a very simple surface set here in order to explain the concepts behind getting a G4 blend to work for you. So I have two surfaces here, one on the top and one on the side. Both of them are degree 3 by 3. If I turn on the curvature combs, you can see the characteristics of both of these surfaces is that they are slightly bent. They're slightly bent in two directions. Now there are two techniques in order to do this. The first keeps your theoretical intersection, is the technique you would want to use in industry. Uwe Rosbacher has done a presentation about that technique in one of his Autodesk University videos. I highly recommend watching that. I'm not going to do that because it's much slower, and the concepts behind G4 are easily explained in the second technique as well. Now the second technique does not keep the theoretical intersection, which is, of course, to reiterate, it's this line where both surfaces meet each other. That's the theoretical intersection. So I'm not going to have that, but I will be able to explain the concepts of G4 just as well. Now I'm going to go and open my palette. The first thing that I'm going to do here is I'm going to go under surfaces here. I'm going to use a tubular offset. I'm just going to use the values, as you can see here, and then I'm going to click on this surface. I'm going to do a pick nothing, and I'm going to click on the other surface and do another pick nothing. So now what we've got, we've created the opening for our blend to go. I'm not going to keep the theoretical intersection, as I'm going to go into surface edit, and you see trim here. Well, if you click on this and you hold your left mouse button down, you will get a little menu. So I'm going to choose trim convert. I'm going to double click, and I don't want to keep the originals. That will probably be on by default. This first one, then I'm going to click on the second one, do a pick nothing, and reshade. So what you will see now is that we have two surfaces. Both of these surfaces now have the area where the blend will go, so let's go and do that. I just want to reiterate, if I turn on the CV hull, you can see that we lost our theoretical intersection. It's gone. Okay, it is gone. It's not ideal, but trust me, just roll with it. We're going to go to surfaces, and we're going to do a freeform blend. Now, the freeform blend is going to be a G3 on both sides. Single surface, explicit control, 3, because we have 3 in this direction, the U direction in this case. Make sure the flow controls are on edge align for both the start and end. And then we can pick both surfaces and hit the space bar, and we have our surface. So we would think that, alright, we've got this. So what we would need to do in order to get a G4 continuous transition here is we would need to edit these CVs, and these CVs, which is the G3 row. We would need to pinch those in even further in order to get a smoother transition and in order to get G4. Now you can notice the problem with this is it's going to create a radius here that is far too huge, and it's not going to be a smooth transition at all. It's just going to be a pinchy, very sharp transition. So the funny thing is, a curvature comb might give you kind of that G4 look near the zone where the blend begins, but it's not going to give you the G4 feel that you want, which is a very smooth blend. Now, if I put the curvature on here and I choose radius min, you can see it's already a minimum radius of 80, which is about, this is just going to get more insane as we push these further in. So clearly, we can't really touch this blend surface. You know, this surface, turn off its CV hull. We can't touch it. There's nothing we can do to that in order to make this G4 transition. It's just not going to work. What do we want to do? Well, it's really simple. It's based on two concepts. The first concept is you need to have enough room for that fillet to go, for that surface to go. For this surface needs to be much bigger so it has more room in order to get that gradual smooth transition going. The second thing is our primary surfaces, if we look at the curvature comb characteristics, you can tell it's just an arc. It's not doing anything. It's just an arc. Even at the tangent edge where the transition happens from primary to secondary surface, it's not helping at all. We need this surface to help along to create the G4 transition for this blend in order for that to work. So it's really quite simple if you understand the basic concepts. We're going to use Transform CV for this, and if I turn it on and then you hit the space bar, you get this little radial menu depending on the version of Alias that you're on. And we're just going to use two tools. It's really easy. Slide, hull. That's what we're going to use in order to get this transition done. But first, I actually want to select all the surfaces and open my tools palette. Go to Evaluate and choose Dynamic Section. Then choose your right plane and move it around in case that you must. And then you will see this little red section line. We want to turn on persistent sections and curvature on. And this actually looks about right. If it doesn't, you can adjust the scale here. The scale is all relative. You know, you don't really care about the scale. The scale that this has in proportion to this, that's what matters. So you can pick any scale you want. I want a pretty drastic scale so I see what I'm doing. And sampling rate at 90 sounds good too. So I'm just going to go out of here. And I'm going to go back into Transform CV. And I'm going to, it's still on Slide Hull because it remembers the last setting there. And what I want to do is really just two things. I want to do, let's do this multicolor shader thing so you can see better the differences. I want to do this until I have light colors. There, that's good. So you can see clearly where each surface is, right? So I'm going to pick on this. That's the tangent edge. We want this to be much bigger. So we want to slide it further back. Notice what this does. It's amazing. The difference is huge. It's absolutely huge. Just giving it more space for the fillet to run immediately makes the situation enormous amounts better. Because notice two things. Around this region, it's much smoother. And around this region, which is the opposite surface, it's much smoother as well. Notice the peak radius here has decreased dramatically. If we already pick this surface, right, and we put the curvature columns back on, you can see the minimum radius is now 131, which is already a lot nicer. It's already less pinchy. We're giving it that room that it needs. And of course, Alias is a terrific piece of software because this blend, if I go back into its history, it's G3. So, if you've got a recent enough version of Alias, you can enjoy this. It will help you. It will help you. It's not mandatory. You can do it without all the all the automatic stuff, but it will help you. Now, that's one thing. Give it enough room. That's by dragging the actual borders of the surface. Now, if you had the theoretical intersection, that would have been more difficult, right? Because you don't have those hulls to play with. Now, the next thing, I will go back into Transform CV. I will hit the space bar, and I will use exactly the same tools. Slide, Hull Affair. Now I want to pick the tangent row. What the tangent row is going to do, it's going to allow me to have the surface start to accelerate before it actually ends. Notice this. I'm going to slide. It's pretty important to slide this row because if you slide this row, less is going to happen because this is the direction that's already going down. We want to slide in the direction that's pretty straight. So that's actually this direction right here. And we're just going to slide this. And notice that it's growing, right? The curvature distribution along the end of the surface is starting to go up. And when I let go, notice the blend update. Massive difference. Absolutely massive. The difference is night and day. We're going to do exactly the same for the opposite surface now. We pick this hull, which is the tangent hull, and we slide it along the direction of area that's more straight, kind of, right? And we slide this up, and you see it just going up. And if I exaggerate, it's going to go up a lot. We don't want this. We only want it to be maybe about that. We let go, the blend updates, you get that. We actually want a little bit more. Boom, we get that. Maybe we slide this hull back a little bit further so the blend has a bit more space. Boom, we get that. This is already starting to look like G4. It's still got a slight bit of a dip. If we look, no we don't. This is good, right? So basically those are the two concepts. I'm going to go and deselect everything. What I want to show you is each surface separately. So if I select this surface and I use the really cool tool here under Object Display, Hide Unselected, if I do a look at on this, now this is not very large. I'm just going to select the surface and put other combs on, and then I'm going to turn the scale down a bit. Maybe give me some more samples. You can see what it's doing, right? So it's got that R characteristic, and then as it nears the edge that's going to have this G4 transition, it starts going up. It starts flowing into. If you don't do this, you'll end up with arc, right? Like, I mean, you know, it's going to be mechanical. It's not going to be smooth. It's not going to be G4. It will not be what you're after. It will not give you the highlights you want. It will not be the smooth G4 thing that you're after. Okay, I hope I'm clear enough. You must do this. It's a lot of work. Now, here it's pretty easy because I trim converted these, right? If you have to keep in mind that you have this theoretical intersection that you don't want to blow away like I did, this will be more difficult, but the concept is the same. Okay, so I turn this back off. I'm going to Object Display. I pick Visible again, and everything's back. Now, the same is true for this surface. I'm not going to, hide unselected on this one, but you can see, I mean, it's the same thing. The same thing going on here. You have this kind of arc, and then you're starting to go up into the fillet. Then notice the characteristics on this blend. I'm going to turn the controls on because that's important, right? That's important. You always want to check your CVs. And I am going to do a quick object display hide unselected on this because I think it's important. It's important to notice that the start here, right? Think of this tangent length. Think of how long it is. And then here, think of how long that is. Actually, these should be more balanced out so they're about the same length, but, it's a small thing. But think about this length compared to the peak radius and how long that is. That should not be absurdly different. That's important, because otherwise you get that really pinchy fillet that, should be G4, but it's really not giving you what you want. Well, in this case, it is giving you what you want. If I turn the curvature cones on, look at the minimum radius, 162. It's pretty large, and that's what you want. You want a nice, large, smooth blend, right? Well, this will give you that. It needs to have enough space. It needs space to breathe. Now, I'm just going to pick all of that and throw it away. Go to Object Display and Visible again. And, I'm going to show you what you want to know. So I'm going to pick all these surfaces, go back into Dynamic Section. And I just want to uncheck this persistent box, do a pick nothing, excuse me, and it's gone. So I'm going to select everything and do a controls off, which will hide all the CVs, and I'm going to go into the shader thing, right? So if I toggle the model off as well, this is the result you get. This is the result you get, and I'm guessing this is the result you want. Nice, smooth transition. Don't notice where the start and end is. You don't even notice that there's anything different. It looks like one surface. And, you get a very smooth transition on there. If I do the curvature evaluation thing, and you just want to make sure that everything's the same color. Preferably blue, because that's what it should be. But it doesn't really matter. As long as it's the same color, you'll be fine. And then I'm going to go into here. I like mean. It's a bit like Brink Max, but it doesn't blow up on you when you enter really large values, so that's good. We always like things that don't blow up on us. And now if we, just keep sliding this, we don't have that trumpet shape, it's very smooth. It's not going up and down in a wavy pattern or anything like that. And then as we get close to the tangent edges, it bleeds into the main surface like butterscotch. It's good. Now, Gaussian is generally like mean, but like a million times less tolerant, because Gaussian will show you any and all problems you've got, even if they're not really big problems. Even then you can tell, this is just great, right? This is great. Now, we enter a value here. We can go beyond what the scale will allow us to do and then just go back. So you can tell this is the kind of transition that we're after. This is a transition that we've got when you're looking at it with a highlight. And then this is about the patch layout, for this simple surface set, of course, it's easy to demonstrate. So the relationship between the length, like the arc length of this compared to the length of that, it's pretty huge. The fillet is about maybe a third or a fourth as big as the primary surfaces are. It's pretty big. You can make it even bigger if you want to. You just can't make it any smaller than this if you want a G4 transition. This is the minimum that it takes. You can make it bigger all year long, but this is the minimum that you need in order to get a G4 transition in this scenario with this surface set. I highly suggest that you look at Uwe Rosbacher's video as well, because it is excellent, and it doesn't destroy your theoretical intersection, which my technique does. Now, why is it important not to destroy your theoretical intersection? Well, there's just one reason. Unfortunately, it's a very good reason, and that is, if a design change happens, typically the standard industry workflow is as follows. You delete all your blends, you bring your surfaces back to their theoretical intersection, and then you would make your adjustments, your big general shape adjustments, and then you put your blends back in. You put your fillets back in, and so forth. It's fast, it's easy, it's reliant, and it will work every time. Tough luck. I don't have them anymore. I have a big hole here, and there's no way to really get the theoretical intersection back. And, I could use a tool like under Object Edit Extend, and I could desperately try to extend this kind of like along the curvature direction, but it's not going to give me the original because we already tweaked the tangent CVs, and that will, affect the way that extend works. But in this case, it can't give us the original configuration because we were screwing around with, like this hull line, right? We're screwing around with this, so this angle here is really way too sharp. And it's not what our theoretical intersection angle was, so we'd have to do a lot of work there. So, that's why you want to keep the theoretical intersection. However, for the purposes of demonstrating G4, to recap really fast, G4, what do you need? Not just the fillet matters. The primary surfaces that it's connecting to have as much play into that transition as the fillet surface piece itself. You need enough room for the fillet to occupy in order to in order to allow it the distance. I hope this video was helpful to you.